This lesson is very exciting. We're going to create our first Roku channel. This is a basic channel that gets the videos from our content feed and displays them in a grid. The grid contains rows of thumbnail images for the videos, which are referred to as posters. When you scroll to a poster, it gains focus. When this occurs, the poster is highlighted and its name, duration, and description are displayed above the row using labels. In this lesson, you'll learn how to create SceneGraph components, set their attributes, and create their interfaces. You'll also learn how to use BrightScript to parse the metadata in the content feed, add the metadata to content nodes, and then add the content nodes to the SceneGraph components in your channel. To get started, we need to create a directory that will contain the SceneGraph components, BrightScript code, artwork, and manifest for the channel. Let's name the directory GridScreen and then create 3 subfolders: Components, Source, and Images. In the Images directory, we need the logos, splash screens, and other artwork for our channel. In the Resources section, click the channel artwork link to download some sample artwork. Add these files to the channel's Images folder. In the root directory, we need a channel manifest, which contains the channel's name, version, paths to artwork, and other attributes. Every channel must have a manifest so the Roku OS knows which features your channel supports. To create the manifest, open a new file in your text editor or IDE and provide the following basic attributes, which are required for all Roku channels. The channel details, which includes the title of the channel that will be displayed on the Roku home screen when the channel is highlighted. You can enter any string here. Also enter the major, minor, and build numbers. Once again, you can enter any numbers. Also, we need to include the channel artwork. This includes the icon that will be displayed for the channel on the Roku home screen. We'll specify this HD icon in the Images directory. We also need to include the splash screen that will be displayed when the channel is launched. And we'll specify this HD splash image in the Images directory. Let's also add the optional UI resolutions attribute and set it to HD to indicate that our channel is designed for HD displays. And that's it. So let's save this file in the root directory and name it manifest. The first thing we're going to do is create a screen and a scene. A screen is a canvas that displays the channel scene. The scene functions as the root component in a SceneGraph channel. It contains all the SceneGraph components used to build the channel UI. Roku channels typically have a single main scene. To create the screen and main scene, open a new file in your text editor or IDE and create a component named MainScene that extends the scene component. Let's add a script element that points to the corresponding MainScene BrightScript file, which we'll create in the next step. The MainScene BrightScript file will serve as the main entry point to our channel scene. Next, let's add script elements that handle the logic for showing and closing screens, parsing metadata in our content feed, and managing the grid screen, which displays all the content. We'll create these files and their parent UI logic directory a little bit later. Now let's add 2 UI components to our channel scene. This includes an information bar at the top called an overhang, and a label that displays loading if content is waiting to be loaded. These components are defined in the main scene, so they will be used on every page in our channel. First, we'll create the overhang. We'll enter the overhang tag, set its ID to overhang. The ID field enables the component to be accessed and modified in a BrightScript file. Then we'll disable its show options and show clock attributes. This blocks the clocks and options prompt from being displayed in the overhang. We want the Roku developer's logo in the overhang, so we set the logo URI field to this logo in the Images directory. And finally, we set its position in the main scene and close the tag. Next, let's create the loading indicator, which is a label. So we'll enter the label tag, set its ID to loading indicator, set the text displayed on the screen to loading, set its width, height, and position. We'll horizontally and vertically align the text in the center, set the visible flag to false so it's hidden by default, and then set its font. And we're done creating the scene. Name this file MainScene.xml and save it in the Components directory. Now let's create the main scene node in the channel's main BrightScript file. To get started, create a new file in your text editor or IDE, and then create a main method which serves as the channel's main entry point. In this method, we'll create a single showChannel.rsg_screen method that creates the screen and main scene, shows the scene, and listens for screen events. In the showChannel.rsg_screen method, the first thing to do is create a screen. To do this, create an RowSG_screen object and store it in a variable named screen. This is a SceneGraph canvas that displays the contents of a scene. Add a message port to listen for events on the screen and handle them. We'll store this message port in a variable named port and use the m.attribute to make the message port accessible to the whole main scene component. Let's set the message port that will be used to get screen events. Add the main scene to the screen using the screen's createScene method. And then call the screen's show method, which creates the scene following the standard initialization order. First, the child nodes inside the MainScene.xml file are initialized in the order listed. Then the fields of the specified components in the main scene are initialized. And then finally, MainScene's init function is called. Let's add an event loop that waits for events on the screen. The way we do this is to create a while loop, call BrightScript's built-in wait function, which takes two parameters. The first is the number of seconds to wait for events, which is typically set to 0 to have the port indefinitely wait for events without a timeout. And the second parameter is the message port to listen for screen events, which will be the port we just created. And we store any events generated by the scene in a variable named message. Then we add another built-in function, type, and pass in the event stored in the message variable to get the type of object that generated an event and stored in a message type variable. Now let's add logic to terminate the channel application when the screen is closed. To do this, first check whether an event received on the port is a screen event. And if so, check whether the screen is closed by calling its isScreenClosed method, and then return from the main thread if true. Name this file Main.brs and save it in the source directory. Now that we've created the main scene and configured its appearance, let's program its behavior. Create a new file in your text editor or IDE and create an init function. This function initializes variables referencing the components in the XML file. These variables can then be used throughout the BrightScript file. The best practice is typically to minimize the amount of work in the init function. This ensures components are created without any slowdown. In the init function, we'll set the background of the main scene. You can either use an image or a color. For our example, we'll set the background color to purple. And we'll just set the background URI to an empty string. Then we'll find the loading indicator and store it in an m.loadingIndicator variable, which has component scope. Now, let's call the following three methods used to manage our UI. We'll create each of these methods in the next step. First, init stack screen, which initializes the screen stack. Show grid screen, which shows the grid screen that is used to display the content in the channel. And finally, run content task, which gets the metadata from our content feed. Okay, we're done with the main scene BrightScript file. Let's name this MainScene.brs and save it in the components directory. For the next step, let's create the files for the three UI logic methods we called in the main scene BrightScript file. First, let's add a new folder to the components directory and name it UI logic. This is where we will store our scripts with these methods. First, we're going to create the ScreenStackLogic script. So create a new file in your text editor IDE and create an init ScreenStack function. In this function, create an empty array named ScreenStack and give it component scope with the m.dot attribute. We'll use this for initializing the ScreenStack. Next, we'll create a showScreen function that takes a node representing a new screen, adds it to the ScreenStack, and displays it after hiding the current screen. First, we call the ScreenStackArrays peek function to get the current screen from the stack and store it in a previous variable. Then we'll verify that the screen is valid, and if so, hide it by setting its visible flag to false. Then we add the new screen passed into the method to the main scene, which we reference using the m.top attribute. Then we set the visible flag of the new screen to true, switch the focus to the new screen using the setFocus method, and finally we push the new screen onto the ScreenStack. Now let's create a closeScreen function that takes a node representing the current screen and removes it from the ScreenStack and hides it, and then displays the previous screen in the stack. First, we check that the current screen passed into the method is valid, and that the screen at the top of the stack is valid and is the same as the current screen. We then call the ScreenStackArrays pop function to remove the current screen from the stack and store it in a last variable. We set the visible flag of the screen to false, and then remove the screen from the stack using the removeChild method. Then we get the previous screen in the stack by calling the ScreenStackArrays peek function and store it in a previous variable. Then we'll verify that the previous screen is valid, and if so, display it by setting its visible flag to true, and switch focus to the previous screen using the setFocus method. And our ScreenStack script is done. So let's save it, name it ScreenStackLogic.brs, and save it in the UI logic directory. So the next script we'll create is for the GridScreen UI logic. So once again, create a new file in your text editor or IDE and create a showGridScreen function. In this function, create a component named GridScreen. You do this by calling createObject with the ROSG node as the first parameter, denoting the type of component we're creating, and the name of the component as the second parameter, which is GridScreen. Let's pass the GridScreen into the showScreen method we created in the ScreenStackLogic.brs file. So the GridScreenLogic script is done. Let's save it, name it GridScreenLogic.brs, and save it in the UI logic directory. So the last script we need to create is for the content parsing logic. So again, create a new file in your text editor or IDE. We're going to create two methods. The first one is runContentTask. It creates a MainLoaderTask node for retrieving data from the content feed. Let's name it ContentTask and give it component scope. We'll configure this task node later. Now let's create an observer that monitors the content field of the task node and calls the onMainContentLoaded event handler when the content feed has been parsed. We'll run the MainLoaderTask node and finally enable the loading indicator. The second method is the onMainContentLoaded event handler, which is called when the content feed is finished being parsed. When this handler is invoked, we switch the focus to the grid screen, disable the loading indicator by setting its visible flag to false, and then add content to the grid screen's content field by setting it to the content task's content field. So the content parsing script is done. Let's save it, name it ContentTaskLogic.brs, and save it in the UI logic directory. So now that we've created our main scene, we can start adding UI components to it. For this channel, we're going to add the grid screen. The grid screen contains three components: a row list that contains posters for the videos in the content feed, a label for displaying the video's title and duration, and another label for displaying the video's description. To create the grid screen, first add a new folder in the components directory named GridScreen. We'll create the SceneGraph.xml and BrightScript files for this component in this folder. Now let's create the SceneGraph component first. To get started, create a new file in your text editor or IDE and create a component named GridScreen that extends the group component and puts the focus on the component's RowListChild component when the grid screen gains focus. Let's add a script element that points to the corresponding GridScreen BrightScript file, which we'll create in the next step. Now let's add an interface to the grid screen named Content with a node type. This enables content to be added to the grid screen. Set its alias field to RowList.content. This exposes the grid screen's content field to its child RowList component that we're going to create in the next step. Now let's add 3 children elements to the grid screen. First, add a label node to display the name and duration of the video. Now each SceneGraph component has attributes for configuring its appearance and behavior. For this label, we're going to set its ID to title label. As mentioned before, the ID field enables the component to be accessed in a BrightScript file. Now let's set its width and its coordinates in the translation field. Now add another label node to display the description of the video. Let's set its ID, width, and translation fields. We'll vertically align this label under the title field label. And let's enable its wrap attribute and set its numLines field. This enables the description to be separated into the specified maximum number of lines. And finally, let's add the RowList node to display the posters of the videos. First, let's set the item component name field to RowListItemComponent. This is a custom component for displaying each poster in the row list. This custom component defines the way how each poster will look inside the row list. This will be used for all posters in the row list. Now let's set the ID and translation fields, and we'll position this below and to the left of the labels. Let's set the numRows field to specify the number of visible rows, the row item size for the width and height of the posters in the rows, the row item spacing for the horizontal spacing between the posters, the item size for the width and height of the rows, the row label offset for the horizontal and vertical offsets for the row labels. The row label is the text used to categorize the content in a row. The focus X offset for the X dimension offset of the first fully visible item in each row relative to the left edge of the list. Let's enable the Show Row Label field to display the row label. And finally, set the row focus animation style to floating focus. This causes the focus indicator to float left or right until it reaches the end of the row. Once the focus indicator is at the end of the row, it stays on the first or last item in the row. Content in the row will scroll left or right if there were items that were not visible. And now we're done creating the grid screen. So let's name this file GridScreen.xml and save it in the GridScreen directory. Now that we've configured the appearance of the grid screen in the SceneGraph.xml file, let's program its behavior in a BrightScript file. To get started, let's create a new file in your text editor or IDE and create an init function to initialize the grid screen and its child components. In the init function, we'll use the m.top reference and find node method to find the component at the top of the screen graph named title label. We'll store this in an object reference variable that uses the m.attribute, which makes the variable accessible to the whole component. And then we set the focus to the row list upon its initialization. And we'll use the m.top reference with the component IDs again to find the title and description labels and store them in object reference variables that have component scope. Finally, we'll create an observer to monitor the row item focus field of the row list component. When a content item in the row list gains focus, the onItemFocused handler is called to get the item's metadata. Now let's create the onItemFocused handler. First, let's create a reference variable for the row list component's rowItemFocused field. We can use this to get the position of the item in the row that has focus. And let's create another variable to store all the items in a row. Content references the content node associated with the row list. We will create and configure the content node in the next lecture. And the getChild method retrieves the child node at the index specified in its parameter, which in our case will be the one that currently has focus. Let's get the description of the currently focused item and update the description label with it, and do the same for the title. Now, one additional thing we're going to do is append the duration of the item to the title. To do this, we need to call a getTime function, which we'll create in the next step. We'll use the getTime function to convert the length of the item from seconds to the minute seconds format you see in the UI. The getTime function we're creating takes the length of the currently focused item in seconds, divides it by 60, converts it to a string, and stores it in a minutes variable. It takes the remaining seconds, prepends a 0 if it's less than 10, converts it into a string, and stores it in a seconds variable. The method returns a concatenation of the minutes, a colon, and the seconds to create the minutes second format. And so now we're done configuring the behavior of the GridScreen component. So let's save it and name it GridScreen.brs and save it in the GridScreen directory. Now let's create the RowListItem component that we referenced when building the grid screen. The RowListItem contains a poster for displaying an item's thumbnail. To create the RowListItem, first add a new folder in the components directory named RowListItemComponent. Once again, we'll create the SceneGraph.xml and breadscript files for this component in this folder. To get started, let's create the RowListItemComponent.xml file. So, create a new file in your text editor or IDE, and then create a component named RowListItemComponent that extends the group node. Let's reference the SceneGraph.xml schema too. Now let's add an interface element with an ID of item content, a node type, and an observer that calls the onContentSet handler when the content in the row list gets updated. Finally, let's add a script element that points to the corresponding RowListItemComponent breadscript file, which we'll create in the next step. To configure the RowListItem UI, we just need to add a poster child node to it. So let's set the ID to poster. Let's set its width, height, and load height fields of the poster. The load fields preserve the aspect ratio of the poster image while it's being loaded. Let's set the load display mode field to scale to fit. This way, this scales the images to fit into the target screen while preserving the aspect ratio, but letterboxing or pillar boxing the image. Name this file RowListItemComponent.xml and save it in the RowListItemComponent directory. Now let's configure the behavior of the RowListItem component. So let's create a new file in your text editor or IDE for the breadscript code and add the onContentSet event handler. This function is called when the RowListItem's item content field is updated after getting the metadata of an item. When this occurs, we need this method to get the content item in the RowListItem and store it in a variable named content, and then verify that the item is not invalid, and then get the URL of its thumbnail image from the item's HD poster URL field and add it to the URL field of the RowListItem's poster. So now we're done creating the breadscript file for the RowListItem component. So let's save it, name it RowListItemComponent.brs in the RowListItemComponent folder. So the final step in programming our channel is to add a task for loading content into the grid. To create this content loading task, we first need to add a new folder in the components directory named tasks. Now let's create the MainLoaderTask.xml file. To get started, let's create a new file in your text editor or IDE and create a component named MainTaskLoader that extends the task node. Add a node interface to the MainTaskLoader named Content. This interface is used to update an instance of this component in the MainScene breadscript file. Finally, let's add a script element that points to the corresponding MainLoaderTask file, which we'll create in the next step. Okay, so our MainLoaderTask component is complete. So let's save the file, name it MainLoaderTask.xml and save it in the tasks directory. Now, let's configure the behavior of the MainLoaderTask component. Get started, let's create a new file in your text editor or IDE for the BrideScript code. And then let's start by adding an init function that sets the getContent function. This function builds a tree of content nodes representing the content to be displayed in the grid screen. It is executed when the node interface of the MainLoaderTask instance in the MainScene BrideScript file is set to run. In the getContent function, create an RO URL transfer component. This component is used to get data from a remote server. In our channel, we'll use it to get the videos and metadata from the content feed we reviewed previously. The feed uses HTTPS, therefore we need to use the Roku default certificate. We can then set the URL of the RO URL transfer component to our content feed. In order to retrieve and parse the content feed, let's use the getToString method to return the contents of the feed as a JSON string, and we'll reference the string with the RSP variable. So the next step is to parse the feed and build a tree of content nodes that we'll use to populate the grid screen. First, let's create an empty array. I'll name this root children. Let's create a rows associative array. We'll use this to temporarily store the metadata for the videos in the content feed. Then convert the content feed JSON string to BrideScript components using the parse JSON method and reference the results with a JSON associative array. As long as the JSON variable is valid, we'll take each key in the feed and assign its value in the value variable. We'll check the type of each value. So for the RO array objects like the series, movies, and short form videos, we'll add them as separate fields in the rows associative array. Now let's parse each item in the RO array objects and push them into separate arrays in the rows associative array. For this channel, we're only interested in movies and short form videos, so we'll add code to ignore any series content types in the feed. Series require additional logic to parse the seasons and/or episodes in them. We'll handle these in a later unit. So for the movies and short form categories in the feed, we'll create an empty associative array named row and set a title field to the name of the category and a children field to an empty array. Now for each video in the movies and short form categories, we'll call the getItemData method, which we'll create in a second, to get the item's description, poster URL, title, and release date, and then push the video into the children fields array. Now we can add the parsed arrays of movies and short form videos to our RowList component. To do this, we'll create a root content node, and then we'll set its child content nodes to the video stored in the children fields array using the update method. Finally, let's use the m.top attribute to find the content field of the row list and populate the row list with the rows of content in the root content node. This update triggers the onMainContentLoaded observer in the MainScene BrideScript file, which switches focus to the grid screen and loads the content in the grid screen's row list. The next thing we need to do is create the getItemData method. This method is used to copy the metadata in the content feed to a content node. It takes an associative array, which we'll reference with the video parameter. First, let's create an empty associative array named items. Now we'll try to use the long description of the content feed as the description displayed on the grid screen. So let's make sure it's not invalid and then store it. If the long description is invalid, we'll use the short description. Then we'll set the HD poster URL to the thumbnail field, the title, release date, and ID fields to the similarly named fields in the content feed. Finally, we'll verify that the content field in the feed is valid, and if so, set the length to the video.content.duration field. Let's return the item associative array and end this function. Okay, we did it. The main loader task is done. Let's save this and name it MainLoaderTask.brs in the task folder. And congratulations, you finished building your first Roku channel. So now that we've finished creating our channel, let's test it on a Roku device by sideloading it. First, make sure you've enabled developer mode on your device. You need this to sideload channels. To enable developer mode, take your Roku remote control and press home 3 times, up twice, and then right, left, right, left, right. Accept the license agreement and enter a password for your device. Now your device is ready. Go to the root directory of your channel and zip all the contents. Open a web browser and enter the IP address of your Roku device, and then enter Roku dev for the username, and enter the password you created when you enabled developer mode. In the development application installer, click Upload and then select the zip file for your channel. Click Install. The channel is automatically launched. You can see the overhang in the channel is using the purple background color and the Roku developer logo we specified. You can see that the grid contains rows of video thumbnails from the feed. Each row is labeled with a category name. When you highlight a video, the metadata we specified in the grid screen is displayed above the video. This includes the name of the video, duration, and the description. Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.